we have one more derivative to look at and learn about here, and that is our inverse trig functions. So, little review about trigonometry. Remember that trigonometry is based in right triangles, and when we find a sine or cosine, we're looking for a ratio. And then we have these things called the inverse sine. And we read this as the inverse sine of x, or the arc sine, or sometimes we see it written as a sine. It's short for arc there. So the inverse sine, or the arc sine, is asking a question. It's asking, what is the angle that has a sine of x? So this is telling us that theta has a sine of x, or theta has an arc sine of x. All right? So let's try this out here, all right? First, before we dig into that, we've got to investigate these right triangles a little bit here. So here I've got a right triangle. Now this triangle has an angle of theta, and we'll call this x and 1. So this is the triangle that has a sine of theta is x. Okay, so the sine of theta is x, or x over 1. Or we can say that theta is equal to the arc sine of x. So when we say we've got a triangle or an angle that has an arc sine of x, this is the triangle that results. Now, we've got a missing side that we're going to actually need. So let's think about the length here. If this hypotenuse is 1 and this leg is x, maybe we'll call this b. Then we can say that b squared plus x squared equals 1 squared. And so solving for b, trying to figure out how long that b is, we can get the square root of 1 minus x squared. I'll let you kind of work that out there. So we get the square root of 1 minus x squared. So we're saying that if the sine of theta is x, we get this triangle, and this is going to end up being the square root of 1 minus x squared. Now we're going to need this in a moment here, the cosine of the arc sine of x. Well, how do we find that? Well, we know that arc sine of x is the angle, so that is theta. So this is just saying, what is the cosine of theta? Well, the cosine of theta, using this triangle, cosine is adjacent over hypotenuse. So this is the square root of 1 minus x squared over 1, but we don't need that 1. In a few minutes, we're going to also need to find the sine of the arc cosine of x. So we have this. So arc cosine is x. That means we have a different triangle here, and this is telling us that for the angle theta, the cosine is x over 1. All right, there it is. Well, what is this side? Well, we could do the same thing to find out that this side is going to be the length of the square root of 1 minus x squared. Call this b and solve for b, and you're going to get this. Now, using this triangle that has a cosine of x, what is the sine of that angle whose cosine is x? In other words, what's the sine of theta? Well, the sine of theta is opposite over hypotenuse, and the opposite is the square root of 1 minus x squared. What if we have a tangent of x? Well, here we have a triangle whose tangent is x. So tangent, opposite over adjacent, all right, is x over 1. So theta is the angle whose tangent who has a tangent of x? Well, using the Pythagorean theorem, let's call this c. 1 squared plus x squared equals c squared. Square root both sides, and we get this is the square root of 1 plus x squared. All right, so the secant of theta here is secant is the inverse of cosine. So cosine is adjacent over hypotenuse, so this is going to be hypotenuse over adjacent. So this is the square root of 1 plus x squared. We're also going to need this guy, the cosecant of the arc cotangent. Well, arc cotangent means we have an angle, whose cotangent is x. So we have this set up. Now I need the cosecant of that. Well, this again is 1 plus x squared, the same as we just had. The cosecant of that, cosecant is the reciprocal of sine. Sine is 1 over this, so cosecant is the hypotenuse over 1. So this is the square root of 1 plus x squared again. So we'll need those in a moment, all right? We're also going to need to find these out, the secant squared of arctangents. Well, secant of arctangent of this, so this is just going to be the square root of 1 plus x squared squared, which is 1 plus x squared. Okay, in just a moment we're going to need the cosecant of arc cotangent squared. So in other words, we're going to need this square root of 1 plus x squared squared, and that is going to be 1 plus x squared. All right, so, well, there's a little practice with some arctangent. It gets a little tricky with those x's in there, but that's how it works. Now let's see how it applies to the derivative. Now one more thing we need to know about an inverse is how the derivative of an inverse relates to the derivative of the original function. If we have two functions that are inverses of each other, well, if you remember, an inverse, here's a function, f of x, all right, f of x here, and it's going to have an inverse that looks something like this. So this is g of x, which is the inverse of f. So inverse functions are mirror images of each other, okay? When we look at the line y equals x, they're reflections of each other, all right? And so what also happens is when we have 2 points, they change their x and y coordinate. So if this is a comma b, then this point is b comma a. Now, what happens with the derivative, remember the derivative is the slope of the tangent line. There's a tangent line there at this point. Well, its corresponding tangent line is here on its derivative. These have slopes that are related to each other. In fact, they are inverses of each other. Okay? So the slope of g of x, or the derivative of g of x at this point, is the inverse of this function. Okay? So the slope of g of x is the inverse of this. So the way we say that is this. The derivative of g prime is 1 over the derivative of f composed with g of x. Okay? So here's a derivative we don't know. Here's a derivative we do know. So the way it works is this. If we have a function f, and we know that f of 10 is 5, and we know that that means that f inverse of 5 is 10. Okay, we also know the derivative of f. Well, how do we find the derivative of the inverse at 5? Well, according to our definition up here, the derivative of the inverse, so that would be d dx of f inverse of x, is 1 over the derivative of f composed with the inverse f inverse of x. Now in this case, what is x? X is 5. All right, so they have 1 over the derivative of f inverse of 5. Well, do we know f inverse of 5 here? We do. It's right here. F inverse of 5 is 10, because f of 10 gives us 5, so the reverse of that, an inverse is a reverse, is that. So that is f prime of 10. Well, we know f prime of 10, that's 1/8. Moral of the story is this. I want to find the derivative of the inverse. Don't know how to do that, but I do know how to find the derivative of the function itself. All right. Well, so what does that mean? What that means is this. If I want to find the derivative of arc sine, That's going to be the reciprocal, or 1 over the derivative of sine, which I do know. Derivative of sine is cosine, composed with the original function, or the inverse function, arc sine of x. Well, what is the cosine of the arc sine of x? Well, looking back at the triangle that we had on the other page there, we said that if we have the sine is x, then this was 1 minus x squared. So if the sine of this angle is x, the cosine of that angle is going to be 1 minus the square root of 1 minus x squared. What about the arc cosine? Well, I don't know how to find the arc cosine, but I can do 1 over the derivative of cosine, the derivative of the inverse, which is negative sine of arc cosine of x. Okay. All right, the arc cosine. This means we've got a triangle from the other side there, the other page I should say, that has an angle whose cosine is x, and we need its sine. So this is going to be 1 over negative square root of 1 minus x squared. Or put this negative up top, and we've got negative 1 over square root of 1 minus x squared. Notice these are very similar. They're just opposites of each other. So arc cosine and arc sine derivatives are the same. All right, well, we could do the same thing there for tangent and all that, but we'll just kind of look at the formulas now. And so here's our formula. The derivative of arc sine is 1 over the square root of 1 minus x squared. Picture that triangle when you think of that. Derivative of arc cosine is the opposite of that. Remember, cosines go negative. It's still holding true. Derivative of arc tangent is 1 over 1 plus x squared. All right, comes from that triangle that had a tangent of x over 1. Then we have the arc cotangent is the opposite of 1 plus x squared. These ones you should definitely memorize. They will show up often. Okay, so those are important. The arc secant, that one doesn't come up as often, so work on it, but it's not as important. It's a little weird here. Arc secant is 1 over the square root of x times the square root of x squared minus 1. And kind of the reason why this kind of repeats is, remember, secant goes to secant tangent. So when you take the derivative, so that's kind of what's going on there. Derivative of cosecant is negative. Again, the absolute value of x all over the square root of x squared minus 1. Okay, here's the u version of it. It's just really the chain rule. All right, so memorize those top ones there. Remember that it's related to the Pythagorean theorem there. All right, so if we want to find some derivatives, a couple quick examples here. The derivative of this, we're going to use our formula here. We've got to take the derivative of the inside. We're using this guy right here. The derivative of the inside is 15x plus 4 all over the square root of 1 minus u squared. So 1 minus u, which is 3x to the 5th, plus 4x squared. There it is. That is it. Okay? So yes, in the end, it comes down to memorizing, but understanding that triangle, or kind of where it comes from, will help a little bit there in making some sense of it. Okay, arc cotangent, well, we're using this one right here. And so we've got derivative of that is negative u prime. So derivative of e to the x is e to the x, but negative because it's arc cotangent. And then that's all over the 1 plus u squared. Well, that's e to the x squared. Or we'd rather write this a little simpler, as in negative e to the x all over 1 plus e to the 2x. Okay. And last one here, arc secant. Again, this one is a little more challenging, kind of a lookup probably, and look the formula up. And so we have the derivative of u, well, that's the derivative of the inside, which is a function itself. So how do you take the derivative of 2x? Well, our natural log of 2x. Well, that's u prime over u. There's our derivative of the natural log of 2x all over this guy right here, absolute value of u, which is the absolute value of the natural log of 2x, times the square root of the natural log of 2x squared, and then minus 1. All right, so notice that square root is very similar there. We might cancel these out, and actually they get 1 over x, multiply top and bottom by x, and we'll have this 1 over x times the absolute value of natural log of 2x times the square root of natural log of 2x squared minus 1. There you have it. That's how it works. So there's our inverse trig functions. End of the day, we just got to memorize it, but hopefully that triangle helps it make a little sense and gives you a little bit of something to anchor it to there.